Good evening, children.
Good evening.
Good evening.
Good evening. Good evening.
Good evening, ma'am.
Good evening, children. We stopped here in the 10th one in the last class. We have an alternate method to this proof. We'll see that now. What we saw in the last class is you can see here angle ABC, that is angle 1 is 90 degrees, and this angle DCB is also 90 degrees. So it's like, did I explain this, children, in the last class?
Yes, ma'am.
Okay, so AB is a line, AB is a line, DC is the other line, DC is the other line, and BC is the transversal. BC is the transversal. AB is a line, okay, line segment, and DC is the other line segment. This is the transversal. You can see this is already 90 degrees. This is already 90 degrees. So we have two lines intersected by a transversal such that co-interior angles are supplementary. We have two lines intersected by a transversal in such a way that co-interior angles are supplementary. They are supplementary. 90 plus 90, 180. Co-interior angles are supplementary. That means these two lines must be parallel to each other. So that's what you see here. That's what you see here. So AB is parallel to CD. Now we have to prove that triangle CED. We have to prove that triangle CED is similar to triangle ABC, which means we'll have to take up these two triangles. So in triangle CED and in triangle ABC. See, first prove that these lines are parallel. Prove that AB is parallel to DC because co-interior angles are supplementary. AB is parallel to DC. That's what you have to do first. And then take up the two triangles. The two triangles are CED and ABC. Take up the two triangles. Find out, look out for the equalities. Look out for pairs of angles that are equal. See, one angle should be from the first triangle and the other angle must be from the second triangle. So like this, you have to bring out pairs of equal angles or pairs of equal sides. All right, so in these two triangles, CED and ABC, angle 5, can you see here? See, children, we have to prove that this is what it is. We'll have to prove CED is similar to ABC. So in triangle CED, can we see angle 5? In triangle CED, see angle 5 here. Angle 5 is 90. And in the other triangle ABC, angle 1 is 90. So angle 5 of triangle CED is equal to angle 1 of triangle ABC because each of it is equal to 90 degrees given. Next. See here. Now that we have proved that these two lines are parallel line, transversal, parallel line. Alternate interior angles are equal. So angle 4 of the small triangle is equal to angle 2 of the big triangle. Angle 4 of the small triangle CED. See, you will have to write one angle of the small triangle equal to one angle of the large triangle. So angle 4 of the small triangle CED is equal to angle 2 of the big triangle ABC. Why? Because alternate interior angles are equal. So this is sufficient. Now, by AA similarity criterion, the two triangles are similar to each other. What is important is the way you name the triangles when you use the similarity symbol. When you use a similarity symbol, the order in which you name the triangles is very important. We know the triangle ABC is the same as triangle BAC. Triangle ABC, triangle BAC, triangle CAB, triangle CBA, all refers to triangle ABC. Triangle ABC. Triangle ABC can be called triangle BCA, BAC, CBA, CAB, all represents the same triangle. But when you're going to use two triangles with this similarity symbol, so we have the similarity symbol here, and we have one triangle, a triangle on either sides of the symbol. Then the order in which you name the triangles, the order in which you place the vertices is very important. These letters, the order in which the letters of the triangle appear is very important. So you'll have to match. So angle 5 goes with angle 1. So angle 5 is what in the small triangle? 90 angle 5 is
90 degree, ma'am.
No, it represents the vertex.
Angle E, ma'am. C
E. So what is angle 1 in the large triangle?
Angle B, ma'am.
So if you say E in the small triangle, you must say B in the big triangle. E of the small triangle is equal to B of the big triangle, because angle 5 is equal to angle 1. So the vertex E corresponds to the vertex B. Vertex E of the small triangle corresponds to vertex B of the large triangle. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yeah. Now tell me, what angle 4 is equal to angle 2. So which vertex of the small triangle corresponds to which vertex of the large triangle?
C, ma'am.
See, vertex C of the small triangle corresponds to
A, ma'am.
Yeah, so C of the small triangle, because angle 4 is vertex C. So C of the small triangle corresponds to 2, A of the large triangle. So it's A here. So vertex E goes with vertex B, vertex C goes with vertex A. So then the third vertex, which is the third vertex EC, which is the third vertex of the small triangle?
D.
D. And which is the third vertex of the big triangle?
C, ma'am.
C. So ECD similar to BAC. Can also be written as CED, the second letter, the first letter, and then the third letter. CED similar to ABC. When you change the order here, change it in the same way here. If you want to write C first, if you want to say CED, then you must say ABC. Do we understand that?
Yes, ma'am.
Yes,
Others?
ma'am.
Okay, now tell me then, if I want to call it DEC, DEC is similar to
A,
DEC similar to
CBA.
CBA or ABC.
C, B, DEC, CBA. No, I heard something incorrect. I don't know who said that. Was it Shakti? You said ABC or BCA?
Ma'am, I said ABC.
Shakti, that's wrong.
Okay.
No, but you should think why. Now tell me, Shakti, if I say DCE is similar to Shakti, DCE is similar to
Ma'am, ACB.
in the small triangle, which vertex is D? The third vertex here.
Yes.
Then the second vertex C.
Yes.
And then the first vertex E. Change it in the same way here.
And CAB.
Yeah, CAB. CAB. Are you sure about that?
Yes, ma'am.
Okay, if I say, Shakti, if I say EDC, EDC is similar to? EDC is similar to?
Ma'am, BCA.
BCA. All of us agree?
Yes,
ma'am.
Children, this is very important. Only then you can find the other, results that follow when two triangles are similar. No, somebody here does not understand. Anybody here does not understand. Please ask me. We cannot proceed further without getting this clear. Let me just do it again. Do we understand that we have two triangles, one small triangle CED and one big triangle ABC? Can we see that?
Yes, ma'am.
We are just calling CED as a small triangle just to understand. Nothing to do. Yeah, so nothing that you should always use the words small and large. Not like that, just to understand. So we have two triangles here, one small, one large. So the small one is called CED, the large one is called ABC. We are trying to prove that they are similar. That is, if you enlarge the small triangle, if you enlarge it, at the point it will look, it will take the size of the big triangle ABC. When you zoom in to this triangle, this small triangle, at a point it will take the size of this big triangle ABC. Or when you zoom out of this triangle, when you diminish, when you reduce the size of this triangle proportionally, then at a point its diminished version, the diminished version of this triangle, at some point it will look like this. When you keep diminishing the size of this big triangle, at some point it will take this size, the size of the small triangle. That's why we say that two triangles are similar. Okay, so we need to, this is how we present the answer. Mention the two triangles. Here you can name them in any order. You can call it CED, CDE, DEC. Here the order is not important. When you write the triangles on either side of the similarity symbol, then the name of the way you name the triangles is very important. The order in which you place the letters, the order in which you place the vertices become very important when you use the similarity symbol. Okay, now in the small triangle and the large triangle, you can see it here. Angle 5 of the small triangle is equal to angle 1 of the large triangle because 90 degrees. You must mention one angle of the small triangle and another angle of the big triangle. You should not simply write they're equal. Don't think we can just write 5 is equal to 1, 2 is equal to 4. No. Why are we saying angle 5 is equal to angle 1? Because it's marked 90 degrees. And the measure of angle 5 is 90. The measure of angle 1 is also 90. So 5 is equal to 1. We cannot simply write one angle from the first triangle, one angle from the second triangle and simply say they're equal. No. They're equal because both of them measure 90 degrees. And then angle 4 of the small triangle. See, 4 is only this one. It's only of the small triangle. 4 is only this one. I have marked this portion as 4 and this portion as 3. These numbers are given by us. It will not be given to you in the figure. Just to make it convenient to name the angles, we use the numbers. So angle 4 is equal to angle 2 because alternate interior angles are equal. We don't know the measure. We don't know how much 4 measures, how much 2 measures, but whatever, they are equal in measure. Whatever is the measure of angle 4, the same is the measure of angle 2. We don't know what they measure. So now by AA, because here one pair of equal angles, another pair of equal angles. So double A similarity, the two double A similarity criterion, or double A similarity, the two triangles are similar. Now, the most important thing, how to name the triangles. So you can also start with this. I just use this order here. We said angle 5 is equal to angle 1, right? We said angle 5 is equal to angle 1. So angle 5, the vertex in the small triangle, angle 5 is this vertex E. This angle 5 is formed at vertex E. So if you say E in the small triangle, 5 goes with 1. 1 is B in the large triangle. You must say B. Then 4 is equal to 2. 4 of the small triangle. So C of the small triangle goes with 2. A of the big triangle. Then write the third vertices. So in the small triangle, the third vertex is D. In the big triangle, the third vertex is, what's the third vertex? C. And now say they are similar. Now if you want to write it as ABC, see here, ABC. If you want to write this as ABC, you must say, if you want to say ABC, you must say CED. CED. Yes or no, Shakti?
Yes, ma'am.
Yeah. All of us?
Yes, ma'am. Yes, ma'am.
Okay. All right. So this is how we show that these two triangles are similar. In the alternate approach, what we do is, now tell me, in the small triangle, look at the small triangle. Which angle is 90 degrees in the small triangle?
Ma'am, CED.
So we use the numbers, please, if possible. Which angle?
Angle 5, ma'am.
Ma'am,
Angle
angle
5, ma'am.
Angle 5 is 90 degrees. So what will be angle 6 plus 4? What will be the measure of angle 6 plus 4?
90 degree, ma'am.
90. Yes or no, children? In the small triangle, is my voice clear, children?
Yes, ma'am.
Yes, ma'am.
Okay. In the small triangle, angle 5 is equal to 90 degrees. Then angle 4 plus angle 6 is equal to?
Angle 5, ma'am.
Angle 5, ma'am.
No. What is the magnitude? What will be the
90.
value of angle 4 plus angle 6?
90.
90. Yeah. Okay. Now look at the big triangle, children. Look at the big triangle ABC. What's the measure of angle 1?
90 degree, ma'am.
90.
degrees.
Then what is the measure of angle 2 plus angle 3?
90 degree, ma'am.
90 degree.
90 degrees.
So all of you agree, no? In triangle ABC, angle 2 plus angle 3 is 90. All of you agree?
Yes, ma'am.
In the small triangle, angle 4 plus angle 6 is 90. In the small triangle, angle 4 plus angle 6 is 90. Yes or no?
Yes, ma'am.
Yes, ma'am.
Okay. Now, also, angle 3 plus angle 4 is equal to 90 degrees, correct? Angle 3 plus angle 4 is 90.
Yes, ma'am.
Yes, ma'am.
Responses, you are responding, but not promptly, which is why I have a doubt. Is my voice clear?
Yes, ma'am. Clear, ma'am.
Okay, that's what you see here, children. See here, I'll switch and show you. What is it? 2 plus 3 is 90, right? You can see the first one, 2 plus 3 is 90. In the big triangle, see, watch out, in the big triangle, 2 plus 3 is 90, right? In the big triangle, 2 plus 3 is 90. That's what you see here. The first one, 2 plus 3 is 90. Then In the small triangle, 4 plus 6 is 90. Yes or no? 4 plus 6 is 90. You can see the second one. 4 plus 6 is 90. Yeah, you can see the second one. 4 plus 6 is 90. And then we also said this. See, first we take up the small triangle. Okay, not first. Or we have to take up both the triangles. So in this triangle, leave angle 5 because that is 90. So 4 plus 6 is 90. Write that result. In this triangle, angle 1 is 90. Leave that. So angle 2 plus 3 is equal to 90. Then we have to write one more result. See, when you wrote 4 plus 6 is 90, it is only about the small triangle. When you wrote 2 plus 3 is 90, it is only about the big triangle. Now pick one angle from the small, pick one angle from the large. So see here, 3 plus 4 is equal to 90. 3 plus 4 is equal to 90. Do we understand what we are doing?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
All right. So first we take okay, it's not the order which is important. You can write these three results in any order. You can write anything first. There is no order here, but this is how we write the results. So when you take up triangle CED, angle 5 is 90. Leave that. The sum of the remaining two angles, 4 plus 6 is 90. We need to write that result. In the big triangle, angle 1 is 90. Leave that. The sum of the remaining two angles, 2 plus 3 is equal to 90. We need to write that. And after that, we need to write a result which is common to both. So now 3 plus 4. 3 is of the big triangle, 4 is of the small triangle. 3 plus 4 is 19, which is why I have numbered all the angles. 3 plus 4 is 90. So write all these results. Write these results. Right. This is method 2. For method 2, you don't have to prove that the lines are parallel, children. For method 2, you don't have to prove that the lines are parallel. This is different approach. Write these three results, call them ABC and compare. Compare. So this part you can understand, children. Please compare. And once you compare, you get new results. 2 is equal to 4, 6 is equal to 3. Now in the two triangles, we proved that angle 4 of the small triangle, angle 4 of CED is equal to 2 of ABC. 6 of CED is equal to 3 of ABC. So the two triangles are similar by AA similarity criterion. This is another way of doing it. Very important method this is. Now don't say that the earlier one was easier, so we'll use that. This idea is different. This idea is different. So please learn both the methods. Please learn the alternate approach also. Here we don't have to prove that the lines are parallel. Write these three results. Compare. Comparing A and C, you get a new result. Comparing B. Okay, now how do you know which two to compare? So compare. We wrote this result which is common to both the triangles, right? 3 plus 4 is 90. 3 was of the small of one triangle. 4 was of the other triangle. So compare A with C and B with C. You cannot compare A and B because 2, 3, 4, 6. 2 plus 3 is 90, 4 plus 6 is 90. When you equate these two, 2 plus 3 is equal to 4 plus 6. Will give you no new result. Compare A and C. 2 plus 3 is 90, 3 plus 4 is 90. So that means 2 plus 3 is equal to 3 plus 4. We understand why?
Ma'am.
Yes, ma'am.
2 plus 3 is 90, 3 plus 4 is also 90. When you compare these two results, so we have 2 plus 3 is equal to 3 plus 4. 3 on either side gets cancelled. So we have 2 is equal to 4. So B and C again, when you compare B and C, 4 plus 6 is 90, 3 plus 4 is 90. So 4 plus 6 is equal to 3 plus 4. 4 on either side gets cancelled, so 6 is equal to 3. So in the two triangles, you have these equalities, 4 and 6. 4 and 6 of this triangle equal to 2 and 3 of this triangle respectively. So the triangle is similar by AA similarity criterion. I think last class I gave you time to complete everything during the session, right? This chapter is very important. So all of us are finished till the 9th one, right?
Yes, ma'am.
Okay. Write down this alternate method. Continue.
Ma'am, in the last class we finished with the 11th one.
No, I did not explain it. I did not explain this in the last class. Maybe I asked you to write.
I think we
Oh, okay. So you have it in your book, is it? Fine, fine. You have even written the 11th one?
Yes, ma'am, completely.
Yeah, I remember. Yeah, I did not explain, but I had asked you to write. Yeah. Thanks for reminding me. Yes. So in the 11th one, children, so this I leave it to you. You have to take up, two triangles here. You'll have to take up from this figure, you'll have to take up two triangles and show that they are similar. See, what is it? You're given a triangle. Let's understand the figure first. Okay, so we have a triangle with some information like this. There is a line segment ED in the triangle. There's a point E on BC. There's a point D on AC. And there's this line segment ED running through the triangle. And then you have the length of certain line segments, CD, DA, AB, BE, EC and all that. And we have to find X. X is the length. X is the length of the line segment ED. X is the length of the line segment ED. So otherwise, if not for similarity, it's difficult to find the length of ED. Now, with the help of the concept of similar triangles, you will be able to find the length of this line segment ED. How? Take up the small triangle. Take up the small triangle and the whole triangle.
Want to prove that both are similar.
Yeah. Take up the small triangle CED. See, children, there are two triangles here. There are two triangles here. What is this figure? It's a quadrilateral, right? This one is a quadrilateral. Name the quadrilateral in this figure.
ABED.
Yeah, ABED is a quadrilateral. Name the two triangles.
ABC and CD.
Ma'am, ABC and DEC, ma'am.
ABC and
DEC, ma'am.
DEC, yes. So here, children, it's all that. So this figure will be given to you, and you can see here, find X if angle A is equal to CED. See here, if angle A is equal to CED, which is angle A, this is angle A, is equal to CED. CED. Angle 2, angle 1 is equal to angle 2 is given to us. See here. Angle A is equal to angle CED. Angle A is angle 1. And CED is angle 2. CED is angle 2. 1 is equal to 2 is given. 1 is an angle of which triangle?
Ma'am, ABC, ma'am.
Yeah, and 2 is an angle of which triangle?
DEC, ma'am.
DEC. So we have one equality already given to us. Angle 1 of the big triangle is equal to angle 2 of the small triangle. Which is the other information which will help us to prove that the two triangles are similar?
Angle 3 equal to angle 3, common angles.
Yeah.
Angle 3 is a common angle.
Yeah, angle 3 is equal to angle 3 because angle 3 is an angle of the big triangle as well as a small triangle. So angle 3 is equal to angle 3, common angle. So which similarity rule?
AA similarity criteria.
A similarity criterion, the two triangles are similar. What is the order? Vertex A goes with? Vertex A of the small big triangle goes with?
E, ma'am.
E of
E,
the
ma'am.
small triangle. E of the small triangle. Then match the known ones. A of the big triangle goes with E of the second triangle because 1 is equal to 2. Then next one. C of the big triangle goes with?
C of the small triangle.
C of the small triangle. And B of the big triangle goes with?
D of the small triangle.
D of the
D of the small triangle. So like this. So you know, so just you can write this in any order, children. It's not that you should write CED, CAB. Now you tell me. We started with C there, is it? Let's not start with C. Let's start with A. Let's name the small triangle first and then the large triangle. So the small triangle. If I choose E from the small triangle, what should I choose from the large triangle?
A, ma'am.
A.
A, ma'am.
Because in the small triangle, 2 is equal to 1 of the large triangle. So I must say A for the large triangle, A. Then we'll do with the known information first. In the small, this is small, children. Let's not get confused. This is of the small triangle. This one is the big triangle. Okay. So E of the small triangle goes with A of the big triangle. And then C of the small triangle goes with
C of the big triangle.
Because it's a common angle. It's a common vertex to the two triangles. And then which is the third vertex remaining in the small triangle?
D and D.
D. Here it is D. And here it is B. In the big triangle it is B. So this is the order. Now Muthuvel, now these two triangles are similar. Now Muthuvel tell us if I write C D E is similar to what? Is similar to CDE, similar to
CBM.
CDE similar to C B. What do you say? A, correct?
A.
Very good.
Yes, ma'am.
Very good. CDE. If you change it to CDE, then it is similar to CBA. Tell me one more thing, Muthuvel. Tell me a different order.
DCE.
D,
CE.
DCE. Yeah. Similar to
Similar BCA.
BCA. Very good. Thank you. Very good. If you change this to DCE, it is similar to BCA. So this is what it is. So just take up the two triangles, show that they are similar. See what more can be, meaning it cannot be made more easier. One pair of equal angles given. Angle A is equal to angle CED. And then one common angle. That's all. You just have to write. And make sure that, see now angle 2 and angle 3 is of this triangle CED. And angle 1 and angle 3 is of the second triangle ABC. See, that's the way you present it, That's the way you present it. Please, we have mentioned CED first and then ABC. We have mentioned triangle CED first and then triangle ABC. So here, the information here should be about the triangle CED and the information here should be about the triangle ABC. Like these two should be the angles of CED and these two should be the angles of triangle ABC. So when you write it carefully like that. So these two pairs of angles are equal. So the triangles are similar by the AA similarity criterion. Now that the triangles are similar, their corresponding sides will be proportional. In similar triangles, corresponding sides are proportional. Once the triangles are similar, their corresponding sides will be proportional. So how do you write the ratio of the corresponding sides? This order, only if you write this order correctly, can you get this proportionality correctly. So now see here.
Screen is not shared, ma'am.
Sorry?
Screen is not shared, ma'am.
I have shared my screen.
Ma'am, that is not.
Ma'am, it is
Ma'am,
blank,
now
ma'am.
For some time.
No, not visible, ma'am.
Okay. 1 minute. All of us? Children, is my screen visible to any of us here?
No, ma'am.
For me, it is visible, ma'am.
Yes, ma'am. For me, it's visible, ma'am. It is visible, ma'am.
Yes, ma'am, visible.
Yes, ma'am. Visible, ma'am.
Children, for those for whom it's not visible, just try to leave the meeting and join and check. Because I think if it's visible for some of them, I don't have to check anything from my end. Please leave the meeting and rejoin. I'll wait.
Yes, ma'am. Now it's visible.
Okay, good. Please let me know, children. Don't wait for somebody else to say that. If the screen is not visible for you, my voice is not clear, please inform me promptly. Don't wait for your friends to say first. Okay, once you prove the triangle is similar, now we know that in similar triangles, corresponding sides are proportional. So how do we write that? CE by CA is equal to ED by AB is equal to CD by CB. So this is true. Now substitute the values. We have some values given in the figure. Substitute, cross multiply and find the value of X. Isn't it simple, children?
Yes, ma'am.
You don't have to revise anything. The similarity, you just have to remember the similarity criteria, AA or AAA, SAS, SSS. And then name the triangles in the correct order. That's it. Yeah, do this by yourself, similar to the earlier one. Do this by yourself. Please take down figure 12. So whatever is marked, children always remember these numbers 1, 2, 3 will not be marked in the figure, children. That we have to number it for the sake of convenience. It's very easy to name the angles, right? When you use the numbers 1, 2, 3. So now again, you will wonder like, how do you know that I have to mark this angle 1, this one 2 and this one 3? See, actually you will not know. Once you start the proof, see, you want to talk about this angle. So then you mark the angle there. Then you want to talk about these two angles. So as and when needed, go and mark the angles. Before you start the proof, you will not realize that you have to mark this as 1, this is 2, and this is 3. No, even I wouldn't know that. Only when I, start off with the proof in triangle ABC and AD. So then I realize, okay, let me mark the angles that are equal. Let me use numbers to mark the angles that are equal. So then I go to the figure and mark. Again, 1, 2, 3, it's not that all of us should do the same way. You can call this angle 1, this one 2, this one 3. So 1, 2, 3, we mark for the sake of convenience. The other things are given to you. 12 centimeters, 2 centimeters, 3 centimeters given to you. Find AE and DE. Find AE and DE. Oh, AE is here and DE is here, sorry. Yeah. Yeah, the answer is only here in this column. Please do it. I'll also get back in 2 minutes. Please complete this. Last class, I remember I had asked Priyadarshini and one more student. I don't remember. To share, the pictures from the classwork, but I did not receive it. Some students, I don't know if you are all in the meeting.
I sent, ma'am.
Priyadarshini, I did not receive Priyadarshini from you.
Ma'am, I sent, ma'am. You also put okay, no, ma'am. Messaged okay, no, ma'am.
No. I did not receive from you. You might have sent it to some other teacher. I did not receive anything from you. No, that was in a different
Ma'am, I
class.
sent you, ma'am.
Okay, that was a different. Okay, let me not make a mistake. Okay, fine. Let me not make a mistake. But I mentioned the names of 2 students at the end of the class. They were supposed to share the pictures. They did not. Okay, class, use the emoji. Raise your hand. Okay, so this Shriya, Arnav, Shakti, Priyadarshini, Manasa, Muttuveli, Parkavi, Tirunesh, Lakshita, Priya, Srinivasan. No, where did I stop? Shakti, Priyadarshini, Manasa, Muttuvel, Parkavi, Tirunesh, Lakshita, Priya, Srinivasan, Sudarshan, Ravya, Anish, Shivani, Nafi, Rakshan, Aksharam, Ashwin. Shabari. But there is, one mystery to be still resolved. Why, I think about 8 students regularly communicate with me during the session. Where are the others? What do people do? You still have an issue with your mic, not able to unmute and talk. What is the reason? Huh? Many of us. Ashwin has never interacted. So this recording will be very useful for your parents. Ashwin has never interacted. Aksharam has never interacted. Reshmi initially, but not after that. Shruti never. Rakshan only on call, on demand. Otherwise, no. Nafi, no. Shivani, no. Anish, no. Does not communicate. These names, they don't, there is no dialogue. There's only monologue. You only listen to what I'm saying.
Ma'am, I don't have any doubts. That's why I'm not asking anything.
Okay. I don't know what counter reply I must give, so let me just keep quiet. Okay, fine. At least you, mentioned that. Fine. Let me catch the others. So, Sudarshan, yes, Sudarshan does not communicate. Srinivasan, yes. Priya, only on demand. Lakshita has never. Tirunesh, active recently. Parkavi, yes, is active. Muttuvel answers when called. Manasa, never. Priyadarshini was initially, not after that. Shakti, yes, is active. Arnav is active. Shriya is. So I can just mention a few names. Srinivasan, Parkavi, Shriya, Tirunesh, Arnav, Shakti. Have I missed on somebody? Please call your name. That's all. See, 6 names I have. Muttuvel, yes, when I call him, he's always good. He unmutes and he expresses. Please share your answers, share your thoughts. When you communicate, when you connect, it's all the more interesting. But anyways, Reshmi, fine. You said you don't have any doubts, and that's the reason why you don't have to unmute to say anything. Good. I'm happy about that. Children, yes, get back to this 12th one. Complete this. I'll get back in some time. So here again, we just had to take the two triangles, show that they are similar, proportion, because in similar triangles, corresponding sides are proportional. Fill the values. AB can be found using Pythagoras theorem. ACB is a right triangle. ACB is a right triangle. BC is 12 centimeters. AC is 5 centimeters. So by Pythagoras theorem, AB is equal to 13 centimeters. So then equating, we find the values of AE and ED. Any part of the working not clear, ask me.
Ma'am, we want to tell the decimal value.
You can leave it as a mixed fraction. Okay, you can write it as a decimal. Yes. Mixed fraction also will do.
Ma'am?
Yes.
Ma'am, what angle is that we have marked it as a 90-degree thing or it's a circle
90
in the
degree.
figure?
It's 90. It's 90.
Okay, ma'am.
It's 90. It's 90. Angle 1 is 90. Both are right triangles. This is also 90. 2 is also 90. Yeah, it's actually misleading. It is 90. Angle 1 is 90. 2 is also 90. Excuse me. Any questions?
No, ma'am.
No, ma'am.
No, ma'am.
Yeah, let's take up the test. Yeah. I think you can even try the. Okay, this paper has 5 questions, right? 5 questions. 3 from similar triangles, 2, 3, and 4 from similar triangles. 1 is from linear equations and 2 variables, and 5 from statistics. So maybe statistics, you've forgotten the formula to find the median. You can try it as homework. Maybe you don't remember how to convert. What do you call the distribution? What is such a distribution called?
Frequency distribution.
Tell me the appropriate name for this distribution in question number 5.
Less than cumulative frequency.
Yeah, come again. Who was that? Who was that?
Ma'am,
Priyadarshini or Shriya? I can't make out. Okay, children, what's the name of this distribution? It
less
is
than cumulative frequency distribution, ma'am.
very good. I think that's Priyadarshini. Less than cumulative frequency distribution. This one is a less than. This one is a less than cumulative frequency distribution. It's not a frequency distribution. It is a less than cumulative frequency distribution. Please try this. You can try this. Yeah, work the first 4 now. Please work the first 4 questions now in the class. A number consists of 3 digits whose sum is 17. The middle one exceeds the sum of the other two by 1. If the digits are reversed, the number is diminished by 396. Find the number. Just to enable the class to do it, let me just give you some instructions. Assume the digits in the hundreds place, tens place, and the ones place children as X, Y, Z. All of you do that? I hope you've written the question. Please take down the question. Now, what is the first thing? The sum of the number consists of 3 digits. So let the digit in the hundreds place be X. Let the digit in the tens place be Y. And let the digit in the ones place be Z. What will be the first equation? A number consists of 3 digits whose sum is 17.
X plus Y plus Z is equal to
Plus
17.
10y plus 100 is equal to 17.
X plus Y plus Z.
100x plus 10y.
No, the sum of the digits.
Yes.
The digits are X, Y, and Z. X plus Y plus Z is equal to 17 is one equation. The middle one, which is the middle one, Y, exceeds, that means it's more than the sum of the other two by 1. Okay, this is the middle one. This is the middle one. And this is the sum of the other two. The sum of the other two is this one. This is the sum of the other two. See, now if I say that my age exceeds your age, my age exceeds your age by 30 years.
And
My
Y
age.
to X plus Z plus 1.
My age, if I say my age exceeds your age by 35 years, okay, 30 years, it means my age minus your age, the difference between our ages is 30. Understand that. Exceeds means the difference. Something is more, the other one is less. So the greater quantity minus the smaller one is equal to the difference. My age exceeds your age by 30 years. That means I am elder to you by 30 years. Which again means my age minus your age is equal to 30. So exceeds means it suggests a difference between two things. So the greater one minus the smaller one is equal to the difference. So here the middle one is Y. Exceeds. So this is only big. Middle one exceeds. Middle one is more. So this one is to be written first. Exceeds the sum of the other two. This is the sum of the other two. Exceeds means you should put a minus sign. By how much? By 1. So this is the other equation. See it. The middle one exceeds means difference. The sum of the other two by 1. The difference is 1. That means the difference is 1. The difference between which two quantities? The middle one and the sum of the other two. This is the middle one. This is the middle one. This is the sum of the other two. This one exceeds this one. That means this minus this is equal to 1. Then the other information, so you're breaking down the information. There are 3 different things given. The sum is 17 is 1. So we constructed the equation. This is the second one. We finished the equation. Now the third one. If the digits are reversed, the number is diminished by 396. If the digits are reversed, what is the original number, children? What is the original number?
Ma'am, XYZ.
Oh.
100x
Ma'am,
plus
100x
10y plus
plus YZ.
Yeah. The original number is 100x plus 10y plus z. This is the original number. 100x plus 10y plus z. Now the digits are reversed. So it will become z, y, x. Z comes to the hundreds place.
100z plus 10x plus.
So now we have 100z plus
Plus x.
10y plus x. These are the two numbers. This is the original number. This is the original number. And this is the number formed when the digits are reversed. Correct?
Yes,
Now
ma'am.
what is given? If the digits are reversed, that is a new number. The number is diminished by 396. If the digits are reversed, the number is diminished by 396. That means which number is big? The new number or the old number? If the digits
number is greater, ma'am.
Yeah, if the digits are reversed, the number is reduced. The number reduces. The number is diminished. Diminished means reduced. Diminished meaning reduced. If the digits are reversed, if you reverse the digits, you are getting a new number. When you reverse the digits, you're getting a new number, 100z plus 10y plus x. Now this number, the original number is diminished by 396. Like if it is 54, if you make it 45, the number is diminished by 9. If the number is 54 and you write it as 45, you interchange the digits. So when the number 54 becomes 45, it's diminished by 9. 54 becomes 45. It reduces by 9. That means the old number minus the new number is equal to 9. 54, let's assume that 54 is the original number. The new number, when you reverse the digits, 45. The difference is 9. 54 minus 45 is 9. So if the digits are reversed, the number is diminished by 9. The original number, that means the equation will be the original number 54 minus the new number 45 is equal to 9. Similarly here, the original number 100x plus 10y plus z minus the new number 100z plus 10y plus x is equal to 396. Read it again. If you feel why, just read it again. If the digits are reversed, you'll get a new number. If the digits are reversed, the number means the original number is diminished. It becomes smaller now because you've reversed the digits, it becomes smaller. That means the original number was greater. So that means the old number minus the new number is equal to 396. Yes, now try to solve and find the number.
Ma'am, should we do first 4 questions? Ma'am?
No. We'll discuss one by one. No. You finished the first one?
Yes, ma'am.
Oh, in that case, you try. I just want to give some more time. In that case, you go to the second one. Yeah.
Ma'am, is the number is 692, ma'am.
692. I have to, show the second slide, but I think the second slide has the answer to the second one. Let me just check. Yeah, what's the answer? You said Shakti?
692, ma'am.
692. Yes. Srinivasan, what did you get?
Same.
Same. Okay. Correct. 692 is the right answer.
Ma'am, the number is 692.
Yes, Tirunesh, 692 is the correct answer. Only I'm showing you the answer for the first one. Please write down now in the class if you have not finished it or if you were not able to get it.
Ma'am, I done in another way.
Different equations, is it?
Ma'am, yes, ma'am, I have put that x plus z plus 1 is equal to y I have put, ma'am. Then I substituted it with x plus z, y plus z, ma'am. Then I got that 2x plus 2az plus 2, 1 is equal to 17, ma'am. Then I got x plus z is equal to 8.
No, I can't make out much when you read it, but it is possible to do it in different ways.
Good.
You can
Ma'am, can you show the previous slide?
excuse me. For the second one, I can give you a clue. You must take up, see, we have PQ parallel to RB. PQ parallel to RB is in which triangle? Which triangle?
Triangle ABC.
No, that is, you should identify the triangle correctly where you have this, you know, that is, okay, so QP is parallel to RB, right? So Q is a point on which side?
RD, ma'am.
AC.
Ma'am, in triangle RBD, it is parallel.
RD.
PQ is parallel
RBD,
to
ma'am.
RBR, ma'am.
No, I know my question is, wait, one minute, I'll tell you something, wait. See, now if I identify the triangle, you must identify the triangle like this. So you must say triangle ABC. You must say triangle ABC in which DE is parallel to BC. You must say like that. I want such a triangle. See, when I say DE is parallel to BC, you must say the triangle is ABC. In triangle ABC, you can see DE parallel to BC. Similarly, QP is parallel to this whatever AB. Which is the triangle?
ABC.
ABC, ma'am.
No. In ABC, where do you have 1 minute? Okay, you're saying ABC, fine, yeah, okay, I did not see it correctly. Like this. A, B, C, this is P, and this is Q, right? Okay. Now for the other one, for the other set.
In triangle RBD, PQ is parallel to RB.
In triangle
RBD.
RB,
D, ma'am.
RPD, yeah?
RBD, ma'am.
RBD.
PQ is parallel to BR.
Oh, for the same thing you're saying. Okay, for the same thing. No, I'm asking you for the other set of parallel lines.
Ma'am, in triangle ABC, RP parallel to AB.
Triangle ABC, ma'am. RP is parallel to AC, ma'am.
RP is parallel to AC.
Yes, ma'am.
But when you take up these two triangles, are we getting these line segments BD and CD? Or we have to find BD into CD? Or we have to find BD, see a BD into CD? We are only using triangle ABC, where ABC is restricted to this one. ABC is restricted to this. CD. The idea is this: you must take up two triangles in which you have these sets of parallel lines, and in the two triangles there should be one side in common.
Ma'am, we can take BRD and BAC.
See, like I'll tell you now, PQ. I'll tell you, PQ is parallel to AB. It also means PQ is parallel to RB. Yes or no?
Ma'am.
Yes, ma'am.
And we can take these two triangles.
Yeah. PQ is parallel to AB. Also means PQ is parallel to RB. Then RP parallel to AC also means RP is parallel to QC. Yes or no?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
RP is parallel to QC. Is parallel to QC because RP is parallel to AC. RP is parallel to AC. So RP is also parallel to QC. QC is a part of AC. So now you have to, so you will have to identify one triangle which has this set of parallel lines, another triangle which has this set of parallel lines, and the two triangles must have some side in common. It should have some side in common. So let me now, when we do a few others like this, you will be able to identify the triangles. Now I'll tell you for this one, we have to take up the triangles DRB and DRP. See, I'll tell you. DR is the common side. DRB and DRP. What is the idea? You need to take up two triangles which have a common side. So DR is a common side. DR, that is very important. We'll have to pick two triangles which have a common side. So DR is a common side. So I'm saying DRB, DRP. Now, how will this work? In DRB, which are the parallel lines in DRB? PQ is parallel to RB.
Yes, ma'am.
PQ is parallel to RB. What about this triangle DRP? Which are the lines parallel in DRP?
QC is parallel to RP.
QC parallel to RP.
QC is parallel to RP. QC is parallel to RP. Here, QC is parallel to RP. So we have used both the sets. See, this is one set of parallel lines, this is the other set of parallel lines. In this triangle, these two lines are parallel. In this triangle, these two lines are parallel. And why we've chosen these two triangles? Because DR is a common side to the two triangles. Now prove that. Now take up the triangle DRB. DRB. All right. Where's DRB? Oh, sorry. I have to erase everything. Okay, look at the triangle DRB. DRB. This triangle. Identify the parallel lines. These two lines are parallel. Now in this we have two triangles, DQP and DRB. Yes or no? DQP and DRB. Yes or no?
Yes, ma'am.
Yes, ma'am.
I'll draw the triangle. I have to clear it now. Sorry. I'll just show you one triangle. May not be very neat, but just I'm sure you can understand. All right. Is this correct? DRB in which QP is parallel to RB. Is this correct?
Yes, ma'am.
Okay. Now here, since the lines are parallel, corresponding angles are equal, correct? So can I say this angle of the small triangle is equal to this angle of the large triangle? That is in triangles.
Yes,
in triangles DQP.
Yes.
In triangles DQP and DRB. DRB. Okay. So if I call this 1 and if I call this 2. Angle 1 is equal to angle 2. What's the reason? Why is angle 1 equal to angle 2?
Corresponding angles in parallel lines are equal, ma'am.
Yeah. This is 3, this is 4. What do we have next? Angle 3 is equal to angle 4. Why? Corresponding angles are equal. Now then Aren't the two triangles similar by AA similarity criterion?
Yes, ma'am.
See,
Yes,
the
ma'am.
first thing is to identify the triangles. So one of the triangles is DRB. One of the triangles is DRB. In this triangle DRB, we have two triangles DQP, DRB. That is DRB is whole triangle. We have another triangle DQP in it. So take up the triangle DRB, that big one, and the small one inside it, DQP. Wherein these two lines are parallel, that's important, not any two triangles. See here, this is the big triangle DRB, in which we have a small triangle DQP, where this QP is parallel to RB. So in the small triangle, angle 1. See, look at the triangle separately. This is the small triangle. This is the small triangle. And this is the whole triangle. When you see the whole triangle, don't see this line. This is the small triangle. Then when you see the big triangle, don't see this line in the middle. Ignore all this. Just see this triangle DRB, this full triangle without this line in the middle. So angle 1 of the small triangle is equal to angle 2 of the big triangle. Corresponding angle is equal. 3 of the small triangle equal to 4 of the big triangle. Corresponding angle is equal. And if you want, you can mention this. What will you say? Angle 5. Angle 5 is 1 minute. Rakshan? Are you there, Rakshan? Not there? Ashwin? Anish?
Yes, ma'am.
Okay, Ashwin. Ashwin, tell us angle 5. What will you say about angle 5?
Just a minute, ma'am. 1 minute.
No, you cannot take this long. Anish? Reshmika? Reshmika? Okay, then now who has the answer to this question? What can you say about angle 5, children?
Ma'am, it is
Ma'am,
common
angle
for
five
both
is common
triangles,
for
ma'am.
to both
Common for both.
Yeah. Yeah, we can say angle 5 is equal to angle 5 because angle 5 is in the small triangle. Angle 5 is also in the big triangle. Angle 5 is equal to angle 5. If you write this, you say triple A. If you write only 2, say double A. If you write only 2 equalities, you must say double A. If you write all the 3, triple A. Now tell me the order in which the triangles are similar.
Ma'am, DQP is similar to DRB.
Yeah. If you say DQP, you must say
DRB.
DRB. Why? Because D goes with D. D is common. D goes with D. Q of the small triangle goes with R of the big triangle because angle 1 is equal to angle 2. Angle 1 is equal to 2. So Q and R corresponding angles, corresponding vertices. And then here P and B. P and B. Now tell me now that the triangle is similar by AA similarity criterion, what is the ratio of the corresponding sides? We know that in similar triangles, corresponding sides are proportional. So what do we have? DQ by DR is equal to
QP by DB.
QP by
DB, ma'am.
RB.
RB, ma'am.
RB is equal to
DP by DB.
DP by DB, ma'am.
yeah. So this is what you should do. All this you must do. You must take up the two triangles, show that they are similar, and write the proportion. Now, which is the other triangle? DRB. I said DR is a common side. DRB.
I'm triangle DRP, ma'am.
DRP. The other one is DRP.
DRP.
DRP. Okay, let me do it here itself. This one. Yeah. Now again, which are the triangles you should take up here? The small triangle DQC and the big triangle DRP. DQC, the small triangle, and DRP, the big triangle. In the same way, show that they are similar. Corresponding angles are equal. DQC, DRP. Parallel lines, no? So corresponding angles. So this angle of the small triangle is equal to this angle of the big triangle. This angle of the small triangle is equal to this angle of the big triangle. Corresponding angle is equal. You can draw the triangle separately, just using the line segments which are needed for the proof. So in the same way, this is the common angle. Triangles are similar. Write out the ratio of the corresponding sides. Because when two triangles are similar, their corresponding sides are proportional. After this, you can understand. This is what it is. So whenever we do this, children, whenever we do this, we'll always have some ratio. That's why we take up one common side. In the two triangles, we take up, in the two triangles, see, we took up this triangle and this triangle. That is, these two are of one triangle and these two are of another triangle. Yeah, so this is one triangle. We took up the triangle DRB. In DRB, we have DQP and DRB. See here, DPQ and DRB, this one. Children, remember the first triangle we took DRB, DRB. See, you can see it here, DRB. And the small triangle, this one, DQP inside it. They are similar by AA similarity criterion. And this is in similar triangles, corresponding sides are proportional. So we have this. Then with the other triangle is DRP. See here, DRP. DRP. Inside that we have DCQ or DQC. This one. We have to prove that they are similar. And once they're similar, their corresponding sides are proportional. So I'm saying in these two triangles, in this big triangle DBR and this triangle DPR, DR is a common side. So what is the ratio you have on the common side, children? DR, DQ by DR. That ratio DQ by DR will happen in both DQ by DR, because that's a common side to the two triangles DR. So the ratio DQ by DR will happen in both. DQ by DR will happen in both. Now we have to find BD. We have to find BD into CD. Where is BD? Where is BD? This is BD. So you have to take this ratio. There's BD here, no, see here. There's BD here. Children, first time, there's lots to talk about. So Listen carefully. dq by dr is common, okay? Now we have the remaining ratios. Which one to choose? We have to find BD into CD. So there is BD here. Nowhere else there is BD. You check the others. Nowhere else there is BD. BD is only here. So that means you should take this ratio. That is why we have written dP by dB is equal to dQ by dr. dQ by dr we have taken because it's common in both. dQ by dr, dQ by dr. So we write that. And of these two ratios, we take this because it has dB in it. So dP by dB is, see, we ignore this one. We ignore this. We write dP by dB is equal to dQ by dr. From the second one, we write that common thing dQ by dr. And since we need CD, we take, there is this CD is nowhere else. Only here there is CD. So we write this one dC by dP is equal to dQ into dr. Sorry, dQ by dr. So we have 1, 2, 3 ratios here. 1, 2, 3 ratios here. I want to ignore one of it. Of these 3 ratios, I want to drop one. So I drop this one. I drop this. Why? Because this is common. So we go ahead with this. And in this we have BD. So we go ahead with these 2 ratios. That's what you see here. Am I clear, children?
Yes, ma'am.
And in this proportion, okay. So in this proportion, this is common. dQ by dr is common in both. So we write dQ by dr. And now between these two, because this has DC. See, we need to find BD into CD. CD is DC. So we go ahead with this ratio. DC by dP is equal to dQ by dr. Now when you compare this and this, dQ by dr is equal to this. dQ by dr is also equal to this. That means these two are equal. So we get a new proportion now. dP by dB is equal to dC by dP. So see, from these two we get a new proportion. Now on cross multiplying, you get dP square is equal to dB into dC. dP is given to us. dP is 12. dP is 12. So dP square. So 12 square is equal to BD into CD. So BD into CD is 144. The value of BD into CD is 144. So you need a lot of patience. That's what it is. To revise the solution, you need a lot of patience. So step 1 is in identifying the triangles correctly. The two triangles which you identify must have a common side. Only then you will get, in the proportions, you will have a common ratio. Yeah, write down the answer, children. So the steps for these two triangles similar. I have not written because you know it. You just have to mention the equalities, corresponding angles equal. What you have to do is just draw that portion of the figure separately. You can mark the angles 1, 2, 3, 4. You can just say angle 1 is equal to 2 corresponding angles. 3 is equal to 4 corresponding angles. So they are similar by double A. So this is important. DBR is one triangle. DPR is the other triangle. In DBR, you have this small triangle DPQ. In DPR, you have the small triangle DCQ. So this small and this whole triangle, they are similar. This small and this whole triangle are similar. In similar triangles, corresponding sides are proportional. See, how did we write this? From this one. Once you write the triangles are similar, dP by dB is equal to PQ by BR is equal to dP by dr. Again, these two triangles are similar. So DC by DP, CQ by PR, DQ by DR. DQ by DR is common. So we should write that in both. And then since you need to find BD into CD, we'll take this ratio which has BD, we'll take this ratio which has CD. So we'll write this is equal to this is equal to this. And in these two proportions, we have DQ by DR common. So this one is equal to this one. This ratio is equal to this ratio. On cross multiplying, we get DP square is equal to DB into DC. DP is 12, so 12 square is equal to BD into CD. So BD into CD is 144. Very important question. It's a very simple one. I did not write the details for similarity because then the answer will look big and you might feel it's difficult. I just wanted to make it look simple, which is why I've not written the similarity details. Then it will be lengthy and it gives a feeling that it may give a feeling that it's difficult. All right, children, the next one is visible, so you can just see it here. We need to find AD by AB and AE by EC. And then say if DE is parallel to BC. So you can see the ratios are not equal. The ratio AD by DB is 4 by 5. The ratio AE by EC is 3 by 5. AD by DB is not equal to AE by EC. That means DE is not parallel to BC. According to Thales theorem, according to BPT, DE can be parallel to BC only if AD by DB is equal to AE by EC. So since the ratios are not equal, AD by DB is not equal to AE by EC. So D is not parallel to BC.
Ma'am, I am having doubt.
Yeah.
Ma'am, I got the answer in just 2 steps, ma'am. First I have to, by using BPT theorem, I found that PD by BD is equal to QD by RD, ma'am.
Yeah, we can also do using BPT.
Okay.
I'll share that working. I have it in a different material, same question in a different material, or I'll show you in the next class. I promise that I put it on WhatsApp and then I actually have something else to do, and It's just remind me in the next class. It's in a different material. How to work using BPT. I'll show that in the next class. Is the third one understood, children?
Yes, ma'am.
Yes, ma'am.
Since everything is work there, I'm not explaining, children. Please go through and ask me if you have any questions. Try to work the first one again later. Please work the first one again. Second one also. 5 try us. You have to try. We're not doing 5 in the class now. Go back, check the formula. Who can tell me the formula to find the median? Anybody remembers? Don't Google the formula and tell me, please. Recall from your mind. How do we find median?
L plus n by 2 minus CF by F into H.
Very good, yes. L plus n by 2 minus CF by F into H. All right. And the fourth one? Please do the fourth one now.
Ma'am,
Yes.
completed fourth one, ma'am.
Finish the fourth one? Okay.
Yes, ma'am.
Read from your book, Priyadarshini.
Yes, ma'am. In triangle ABC and triangle DEB, angle ACB plus angle DBC is equals to 180 degree, ma'am. Because co-interior angles are made by transversal BC with lines DB and AC of supplementary. So AC is parallel to DB, ma'am.
Okay.
In triangle DEB and in triangle ABC, angle 3 is equals to angle 6 because both are 90 degree, and angle 1 is equals to angle 5 because corresponding angles.
No, 1 minute. Corresponding, 1 minute, 1 minute. Which one have you marked? Which is read the angles.
Ma'am,
Angle
DEB, angle DEB,
angle DEB. You have marked DEB as what?
3,
One.
ma'am. Angle 3, ma'am.
3. Okay, this is 3. Then which is 1?
Angle ACB. 1 is angle DBC, ma'am.
Okay, okay. No. Okay, you read. You don't use the numbers. Name the angles and tell me.
Yes, ma'am. Angle DEB is equals to angle ACB because
Okay.
both are 90 degrees. Ma'am.
Okay.
Angle DBE is equals to angle DAC, ma'am.
Yeah, reason?
Because corresponding angles, ma'am.
No, they are alternate interior angles, right? Are they corresponding?
Yes, ma'am. Yes, ma'am.
Okay. Yeah, they're corresponding angles. Oh, sorry, they're alternate interior angles. Yeah, okay. They're alternate interior angles. Very good. Okay, so then you say that they are similar.
By A similar criterion, they both are similar.
Tell me the order. Tell me, how did you name the triangles?
Triangle EBD is congruent to triangle CAB, ma'am.
EBD is similar.
Is congruent to triangle CAB, ma'am.
Is similar to triangle.
Similar to triangle CAB, ma'am.
CAB. CAB. E goes with C 90 degrees, correct? B goes with A, correct? And then D in the small triangle, C and B, yeah. So next.
So by proportional, EB by CA is equals to BD by AB is equals to ED by CB, ma'am.
Very good. So we get B by D is equal to AC by BC because in similar triangles, corresponding sides are
equal, ma'am.
But you should do one more change, right?
Ma'am, we want to cross multiply and you get answer.
Cross multiplying.
Yeah, correct.
EB into CB is equals to ED into CA, and also that we get B by ED is equals to AC by DC.
Very good, very good. Very confident, Priyadarshini. Very good.
Ma'am, and doubt? No.
Yeah, 1 second. Let me just show the answer. Yeah, children, you can see it here. I think you have to take a screenshot. We have discussed 2 questions which have the similar figure in today's class. So you can help yourself with this. Yeah, Shakti, what's it out?
We don't know that AC is parallel to BD, then how can we tell that alternate interior?
No, she proved that the lines are parallel, no?
Okay.
She proved co-interior angles are supplementary, so the lines are parallel.
Okay.
You can have worked it in both the ways here. You can check this. I've worked it in both the ways. All right, children. So that's it for today's session. How many of you there? Anyone? Should I show the pictures again, children? You need to take a screenshot.
No, ma'am.
All done, no? All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children.
Thank you, ma'am.
Thank you. Good night.
Thank you, ma'am.
Thank you. Good night.